Using the Lewis dot structure of atoms and the patterns listed in Table 3.4, you can draw Lewis dot structures for simple molecules. This slide asks for the Lewis dot structure of water, or capital H subscript 2 capital O, another molecule called ammonia, capital N capital H subscript 3, and methane, or capital C capital H subscript 4. One thing to remember is that hydrogen will always have one single bond. It cannot bond to more than one atom. Let's do the Lewis dot structure for water first. According to the periodic table, hydrogen has one valence electron, and oxygen in family 6A has 6 valence electrons. We start by drawing the Lewis dot structure of the atoms in the molecule. To draw the Lewis dot structure for oxygen, we add 1, 2, 3, 4, 5, 6 dots, and we see that 2 electrons are unpaired. Each hydrogen atom has an unpaired electron. Each hydrogen can share its electron with an unpaired electron on the oxygen atom. We draw those shared electrons as lines, and we have the Lewis dot structure for water. Oxygen has 2 lone pairs of electrons, 2 single bonds, and each hydrogen has a single bond. Oxygen has 2, 4, 6, 8 electrons, and each hydrogen has 2 electrons. This matches the pattern we would expect for hydrogen and oxygen according to Table 3.4. Pause the video and draw the Lewis dot structures for ammonia and methane by drawing the Lewis dot structures of the atoms first. Let's look at ammonia. Since nitrogen is in family 5A, it has 5 valence electrons. We place those 5 valence electrons around the nitrogen atom, 1, 2, 3, 4, 5, and see that there is 1 lone pair and 3 unpaired electrons. Each of the 3 hydrogen atoms can share its electron with one of those 3 unpaired electrons on nitrogen. We draw those shared electrons as lines, and the Lewis dot structure of ammonia has 3 lines, which represent covalent bonds between nitrogen and hydrogen, and 1 lone pair on nitrogen. According to Table 3.4, this is a bonding pattern we would expect from nitrogen. Let's look at methane. According to the periodic table, carbon is in family 4A and thus has 4 valence electrons. We place those 4 electrons around the carbon atom, 1, 2, 3, 4, and there are 4 unpaired electrons. Each of the 4 hydrogen atoms can donate an electron to share with those 4 unpaired electrons on carbon. Since 2 shared electrons is a covalent bond, we draw 4 bonds between the symbol of carbon and each of the 4 hydrogen atom symbols. This bonding pattern matches what is expected for carbon, which always has 4 bonds and never any lone pairs.